Welcome to the second instalment of the new SDVOE API Software Developer course, a series of 8 modules to help guide you through the API command set. At the end of the series, you'll be invited to take an assessment which, when passed, grants you the title of Certified Level 2 SDVOE Software Developer. Throughout this series of modules, you'll be presented with the SDVOE API command set, including the role, syntax and examples of their use. And this course will focus primarily on the core command set. More complex topics such as wall and multi-view will be covered in later separate modules. To help you get a clearer understanding, assignments are included throughout this course, and you're encouraged to complete each assessment to give you better experience. In preparation of this training, you'll require access to the following: the SDVOE API, and that's available for download from the SDVOE Level 1 training resources. The web client application, such as Postman or curl, and 2 SDVOE endpoint devices, where one is configured as a decoder or RX and the other an encoder or TX. Now bear in mind that these endpoints can be set up in either a point-to-point topology or a switch environment. If you choose the latter, you will need to use a 10 gigabit Ethernet switch. Throughout the journey, we're going to take you on a deep dive of the SDVOE API core command set, which is commonly incorporated when developing client applications. Each module includes assignments and a small quiz to help build your understanding of the content within each module. When you receive the Level 1 certification, you are given an SDVOE API toolkit to allow you to build client applications. And it's very important to know how to use these tools. This training will walk you through the toolkit to expand your comfort and knowledge of the SDVOE API. And at the end of the course, you'll be able to demonstrate how to correctly refer to the API developers' user guides to efficiently support the creation of your client applications. And you'll do that by successfully completing the Level 2 SDVOE Software Developer Assessment. Let's do a quick review before kicking off with the API command set. SDVOE, or Software Defined Video over Ethernet, supports video distribution across a standard networking infrastructure, allowing for the routing, configuration and control of AV signals over a 10 gig Ethernet link. The SDVOE API is implemented through a control server which lives on the network. And every SDVOE system is implemented with at least one control server, which could be hosted by a computer, a web browser, or even a mobile application. These hosts contain the software which connects to the API service, allowing the user to control the SDVOE devices on the network. The core API command set covered in this training course will include the following API commands.
This module will provide you with a clear orientation of the course and give you the opportunity to get your toolkit in place before reviewing the API commands used to establish a client session. Module 2 will reveal how to retrieve detailed information about endpoint devices, such as device type, capabilities and stream usage, as well as provide a closer review of how we use event requests and apply query arguments. Module 3 reviews the management of AV streams for encoders or TX devices and decoders or RX devices. Topics covered here include AV stream types and subscriptions, starting and stopping streams, and unsubscribing decoders from an AV stream. Module 4 dives into the API set command and some of its associated arguments, and this command is essential to the management of the Pro AV processor engine. This tool manages advanced functionality, including but not limited to the built-in scaling and video display modes such as fast switch. Module 5 reviews the API requests used for control data such as RS-232, infrared and CEC. We'll also cover how USB routing is established for USB 2 and USB HID. Module 6 reviews the device management tools, including reboot, restoring factory settings, and updating of the Blue River chipsets. We'll cover how to change the current device mode of a transceiver or TR device, as well as how to set a transceiver to function as an encoder or decoder endpoint device. Finally, Module 7 takes a more in-depth look at the miscellaneous API requests available to retrieve data from the API server, including how to retrieve a list of available firmware files or assigned multicast IP addresses. At the end of your journey, you'll be invited to sit the all-important SDVoE API Level 2 assessment, which will test your knowledge, and once successfully completed, you'll be accredited with the title of SDVoE API Level 2 Developer. To gain a practical knowledge of the SDVoE API assignments incorporated into this course, we need to review the recommended SDVoE topology. A 10 gig Ethernet switch drives the network traffic. 2 SDVoE encoders or transmitters are connected to an AV source, and 2 SDVoE decoders or receivers are connected to display monitors. Our host computer or server will run the SDVoE API, and our host computer runs the web client which sends the SDVoE API requests. In this example, we have 2 separate host computers for the server and the web client. However, these could both be hosted by a single computer. It's also possible to work with just a single decoder and encoder if preferred, and it's entirely possible to substitute these endpoints for transceivers, which combine both transmitter and receiver functions into a single endpoint. Finally, for the demonstrations completed in this training, we will be using Postman. However, any suitable tool can be implemented. It's important to note that the built-in capabilities of your SDVoE endpoint devices could impact the recommended assignments. The endpoint could be either an AVP1000 or AVP2000T device, the AVP2000T supporting the AV processor engine, while the AVP1000 not doing so. Other interfaces may also be incorporated into the endpoint device, such as the stereo multi-channel audio, USB, RS-232 or infrared receiver and transmission capabilities. It is important to refer to the endpoint device manufacturing documentation for details on the specific capabilities of your own SDVoE endpoint devices. The SDVoE API includes built-in intelligence, which will return an error if the endpoint device doesn't support the API request being issued. However, we should avoid this by making sure that we're fully prepared. Prior to issuing an API request from the client application, a session must be established between the client and the API server. And this is done by loading the API module from the client using an API require request. For this course, it may first be useful to make the API JSON return data easier to review by setting the client session to display results in human mode. In this mode, the data returned is beautified, with line breaks being added to make the data easier to read. In addition, before loading the API module, it is possible to verify the version of the API server to which the client is to connect. Let's take a closer look at each of these in the order that they would likely be applied. This script enables the human readable output. In this example, we are confirming the version of the API server. Prior to successfully sending an API request, it is necessary for a client to establish a session with the API server and specify the required API module version. the API module specified may have different functionality than an alternate version. Therefore, it's important to make sure that the version loaded matches the version required by the client application. Generally, if an endpoint device supports a previous API version and the application client loads the latest API, compatibility isn't a problem. However, if the client is based on a newer API than an endpoint device supports, an error does result if a new type of request is issued because the device simply wouldn't recognize the request. As an example, in the API version 3.2, the single source wall feature was introduced. So, if a client sends this type of API request to an AVP2000T endpoint device not running firmware 1.3 or higher, then an error will be returned. Don't forget to refer to the API developer documentation for additional information on API versioning and application compatibility. It may have changed since the last time that you checked. Let's go ahead and load the API command module. Here's our command syntax. So, for example, to load API version 3.2, the following request would be issued.
Now it's time for you to establish a session between your client and the API server. In the resource panel below, you'll find a link for this assignment, and when you're ready, head over to Module 2 and we'll see you there.